Hello my friends, I am Krishna and welcome to my channel Go Math. So today's topic is about types of relations. So let's start the video. So there are mainly three types of relation named as empty relation, universal relation and equivalence relation. So what is empty relation? So our first question is, what is empty relation? So empty relation is a relation from set A to B such that no element of set A is related to any element of set B. Is related to any element of set B. So as there is no element of set A related to set B, the relation set results in an empty set, and hence we can denote the relation R by a symbol psi, means empty. Let us take an example. So if we have a set A of students in a boys college, if we have a set A of all the students in a boys college, then the relation R on set A given by A comma B such that A is a sister of B is an empty relation, as the college is for only boys, so there is no girl student present in the college. So I hope you understand what is empty relation. So next move on to universal relation. So how we define universal relation? So let's see. So a universal relation can be defined as a relation from set A to B such that every element of set A relates to every element of set B. So now in universal relation, every element of set A is related to every element of set B. It means the relation set is the whole set A cross B, as the set A cross B has all ordered pairs, and in set A cross B every element of set A is related to every element of set B. Hence we can represent the relation set as the whole set A cross B. Let us understand with the help of an example. So suppose we have two sets. A have 4 elements, 1, 2, 3, 4, and the set B has 2 elements, 1, 2. Then the relation from set A, then the relation R from set A to B given by A comma B such that mod of A minus B is greater than 0 is an universal relation, as the whole set A cross B holds the condition mod A minus B is greater than 0. This condition is held by the whole set A cross B. Hence the relation set R is the whole set A cross B. So I hope you understand this. Let's move on to the next relation, equivalence relation. So what is equivalence relation? So a relation on set A is said to be an equivalence relation if it is reflexive, symmetric and transitive. So now, what is reflexive, what is symmetric and what is transitive? Let us understand. So first start with reflexive. So a relation R on set A is said to be reflexive if A comma A belongs to R for every A belongs to set A. Now the second one is, what is symmetric? So again, a relation R on set A is said to be reflexive if B comma A belongs to the relation set, given that A comma B belongs to R for every A comma B belongs to set A. Now the third one is, what is transitive? What is transitive relation? So again, a relation R on set A is said to be transitive if A comma C belongs to the relation set, given that A comma B comma C belongs to the relation set for every A, B, C belongs to the set A. So I hope you understand what is equivalence relation. So let us solve some examples. So we have an example number 1, where A is a set of all polygons and R be a relation applied on set A such that the relation R is the set of all ordered pairs such that P1 and P2 have same number of sides. We have to show that this relation R is an equivalence relation. So let's start. For reflexive, So let's first solve for reflexive. We know that a polygon is related to itself, and hence the sides on polygon remain same. So P comma P belongs to R, hence R is reflexive. For symmetric, let's check out for symmetric. Now, if P1 comma P2 belongs to R, it implies that P1 and P2 have same number of sides, which in turn implies that P2 comma P1 belongs to R, and hence R is symmetric. Now let's check out for transitive. So if it is given that P1 comma P2 and P2 comma P3 belongs to R, it implies that polygon P1, polygon P2 and polygon P3 have same number of sides, which in turn implies that P1 comma P3 belongs to R. Hence, R relation is also transitive. So hence we see that the relation R is reflexive, symmetric and transitive. Thus relation R is an equivalence relation. So the next question is, check whether the relation R on set A is reflexive, symmetric or transitive, where relation R is given by R is equal to A comma B such that B is equal to A plus 1. So here we try a new approach. Here we solve this by simply writing the relation set in roster form. So in roster form, the relation R is equal to, has all ordered pairs 1, 2, 2, 3, 3, 4, 4, 5 and 5, 6. These are all ordered pairs which are possible in the relation R. Okay, so now we observe that 1, 1 does not belongs to relation R, hence R is not reflexive. Also 1, 2 belongs to R, but 2, 1 does not belongs to R, as we can see. Hence R is not symmetric. and here also 1 comma 2 and 2 comma 3 belongs to the relation set, as you can see, but 1 comma 3 does not belongs to the relation set, hence R is not transitive. Thus, we can see that the relation R is not transitive, not reflexive, and not symmetric. That's all. I hope you understand this. If you like my content, please like it and subscribe it. And in case of any problem, you can comment me in the comment box. Thanks for watching.